In this video, we'll look at exponential smoothing as a method for forecasting, presented in section 6.3, and then linear trend as another method for forecasting, presented in section 6.4. For exponential smoothing, we have a couple of new factors introduced. What we want to do is use an alpha value that we're provided, a sense of market direction, optimism, whatever you want to call it. We talk about it in the textbook. We want to apply that to a forecast. However, the forecast for the first period, we're going to give up 1, so k is going to be equal to 1. We're going to use one period to put a forecast together. We're just going to look to that previous period, the actual value. So our first forecast value will be the previous period's time series value. From then on, we want to weight the actual value with our alpha and add to that our previous forecasted value weighted by 1 minus alpha. So we'll set that up. We'll go ahead and we'll take our actual value from the previous period and we will weight that times our alpha, make that absolute. Then we will add to that, we'll take 1 minus our alpha, make that absolute. And we will use that as a weight for our previous period forecast. That gives us our forecast for period 3. We just copy that down. Go ahead and fix these decimals. That gives us the forecasted values. We can check to ensure that we got our formula correct by pressing F2. We did, so we're in good shape. Now we'll go ahead and just work through the table here. Our error is our actual value less our forecast, and we'll go ahead and copy that down. Absolute value of the error, let's get rid of some of these decimals, equals ABS of our error value. Let's copy that. Take care of these decimals. Now let's square it. Our value raised to the second power. Copy that down. Percentage error. Go over here and get our error value and put it over our time series value. Correct for all of these decimals. Actually, we want to make that a percentage, don't we? It's actually multiplying times 100. Give it a couple of decimal places. Let's copy that down. And then we take the absolute value of our percentage error. There we go. Again, turn that into a percent, essentially multiplying times 100. Carry that down, there we go. Now we're going to total a few of these. Let's draw a line here. There we go, bottom border. Use the sum function. Add those up. Excel tries to help us. Excel is wrong. So we'll just copy these across, convert these to percent, give it a couple of decimal places. The mean forecast error, the formula for that is right here. So we'll take the sum of our forecast errors and place that over our n of 12 minus our k of 1. We used one period for the forecast. Correct for some decimals here. Mean absolute error, formula's right here. We'll use the sum of the absolute error. We'll take our n of 12 minus our k of 1. Correct for those decimal places. Mean squared error, again, the formula. We'll take the sum of our squared values, place that over our n of k minus our k of 1, or n of 12 minus our k of 1. Correct for these. MAPE. Take our absolute percentage and place that over 12 minus 1. That gives us the MAPE. We'll convert that to percentage and give it a couple of decimals. And our week 13 forecast, we will take our week 12 value times our alpha plus 1 minus our alpha times the week 12 forecast, and that will give us our week 13 forecast of 19.18. Next, we'll use the linear trend method to make these forecasts. We're going to use Excel. They present the formulas in the book to calculate the slope and the intercept. We are going to use the Excel functions to do that. You can work through the formulas in the book if you'd like. If you don't have your worksheet laid out like this, you'll want to pause the video and go ahead and set something up. You can leave these equations out the same way here. You can leave this equation out. We're going to do some forecasting here. You can leave all of these things out. We'll put these together in a moment. Just get this basic structure put together. All right, once you have this, the critical parts of doing the linear trend projection is to find the intercept and the slope of the line. So I'll go ahead and do the intercept first, and in Excel we'll use the intercept function. That in our equation is b sub 0 is the y-intercept. This is where our trend line intercepts the y-axis. It's where it crosses the y-axis. Now what it wants is it wants the known y's and the known x's. All right, here are the known y's, and our known x's are the week. The x-axis will be labeled by period, year, week, month, whatever it is. We'll just go ahead and do this. This is a linear trend. Put those in, and that gives us an intercept of 20.4. So in other words, our trend line crosses the y-axis at a sales volume of 20.4 times 1,000. As you can see, sales are in 1,000. Now we want the slope. So how much does it increase each week? So in Excel, we'll use the slope function. We have known y's. We have our y's, comma, and our x's, again, our period here. And we see that each period we increase by 1.1 times 1,000. So we can go ahead now and construct our forecast using the forecast equation here. So our forecast is going to equal the intercept, and I'll have to make that absolute, or b sub 0, plus the slope. I have to make that absolute, b sub 1, times the period. In this case, it's week 1. I'll leave that relative, so as I copy it down, it will calculate that for me. And I'll just double click and bring that down, and there we have our forecasts. Now forecast error, we'll just follow the formula here. Minus. We'll see with this that we could use the standard deviation, but we'll cover that later. And then the forecast error squared equals our forecast error raised to the second power. And we'll take out some zeros. That's why we're getting the pound sign. Got too many decimal places there. Excel trying to help us. And we have that calculation. Now with this, we can go ahead and calculate the sum of the squared error. And we'll get that value right here. And that's the value that we use for one of the calculations that we're asked to do in the textbook, which is the mean squared error, which you can see is the sum of these errors squared. So we'll go ahead and take that value and we'll place it over our n, which is 10. And I'll do it this way just to be consistent. 10 minus, we didn't use any periods to create the forecast. We used the linear trend projection. So that is a 0. So it's just the value over the number of periods. That gives us a mean squared error of 3.07. Now we're asked to create forecasts for subsequent periods, periods 11, 12, and 13. So we end here at period 10. So we'll just go ahead, and I've set this up to make it a little more visual. Here's our formula again, and we'll take our intercept, which is b sub 0, make that absolute. That way we can just copy it down, and we'll add to that our slope, which is absolute again, times the period with a time value. And we've got them set up so we can leave those relative and just copy those down and answer the question. And what are the forecasts for period 11, 12, and 13? It will be 32.5, 33.6, and 34.7 respectively. And that's how you calculate forecasts using the exponential smoothing method presented in section 6.3 and using the linear trend projections presented in section 6.4.